Okay, so today we're going to start with target 1B9. What is the difference between chemical and physical changes? A physical change involves a change in the size, in the color, the odor, a phase, but not a change in what it is. Okay? Nicole can all of a sudden start bathing with shampoo and with soap. Is that going to change her odor?
Yeah.
Yes, she'll start smelling nice.
Okay.
Does that change who Nicole is? Does that change her DNA?
Yes.
No. She can color her hair. Does that change her DNA? Does that change Nicole?
No.
No. She can get contact lenses. Does that change who she is? Those are all physical changes. If you change something without actually changing what it is a physical change. Now, if you change something and it becomes something new, that is a chemical change. For example, here's one that's very subtle. Boil an egg. Is that a chemical or a physical change?
Physical.
Okay, some people will say it's a physical change because it's an egg to begin with and it's an egg afterwards.
But you boil it. So
But after you boil it, my friend, can you change it back to its raw state?
Oh, no.
No, you can't. So if it's not able to be changed back, then we have ourselves a chemical change. We can change Nicole's hair back to blonde. We can put glasses back on her. She goes back to being the old regular Nicole, but did she really ever change?
Yeah.
How about if you fry a hamburger? It's a hamburger to begin with. It's a hamburger afterwards.
But if you can't make it raw.
You can't make it raw again. That's a chemical change.
It'd be cool if you could, though.
It could. You could
Make
redo it if it goes. I don't know. Why would be cool? All right. How about this one? Two clear liquids are going to be added to each other. Chemical or physical? A brilliant yellow crystal forms. New thing formed. New thing formed. Chemical change. Two clear liquids all of a sudden becomes a yellow. What you would find if you could chemically test the yellow crystal is that it's a different compound. That is a solid. It will settle down on the bottom as a crystal. It is. How about this one? Dry ice dropped in water, in warm water. Dry ice is solid carbon dioxide.
Sticking in a bigger piece this time. Yep, lots of bubbles coming up. And one thing you may...
Physical, because you can take it out.
Okay, what's happening to the carbon dioxide? Is it becoming something new?
It's being released.
It's just becoming a gas. In other words, it's just changing address. It was a solid in that block. Where is it now?
In the air.
It's going in the air.
It's like a thing.
Something new? No. This is a chunk of sodium. Okay? A chunk of sodium. This is half of what table salt is. A chunk of sodium added to water.
Chemical.
Can you imagine what would happen if you were to put that in your mouth with as much water? Now think about this. Sodium chloride, table salt, is made up of that and a green gas that will kill you in a second. Put them together and now it's something you put on your french fries.
That's always natural. Yeah. That's natural.
But what happens when it undergoes a chemical change? It changes its personality. It changes its property. When sodium reacts with chlorine, it becomes something new that no longer is dangerous to us. Actually, not only is it not dangerous, it's something we need. Yes, Jeffrey?
It can be dangerous in large amounts.
In large amounts, yes. Of course. This is a strip of magnesium, tough metal.
Physical.
I'm gonna go with
It forms a white powder that's soft. It's almost like talcum. We use it as a laxative. Magnesium is used, well, it's used in its metallic form in weaponry. It's also used as part of the surface of airplanes. But when it does this, it's used as a laxative. New properties?
Chemical.
So, if it was a chemical change, what you saw was a chemical reaction. What is a chemical reaction? A chemical reaction is going to involve breaking and forming of bonds, causing the atoms to rearrange themselves into new compounds. As I said about sodium chloride, usually the characteristics of the new things that are formed are completely different from the characteristics of the things that formed it.